Hey y'all, welcome back to Alakazam Math Made Easy. In this video, we're going to kind of go over a topic that can get a little bit confusing because of how similar terms are, but we're going to cover limits at infinity versus infinite limits, right? And for the purpose of this video, and generally, right, infinite limits are the same thing as limits of infinity, right? So there's a limit at infinity versus a limit of infinity, right? And I think that gets a little bit clearer um, and allows a little bit easier an interpretation of this. So we're going to cover first infinite limits or limits of infinity, right? And we're going to start with this because this is the one that we've already seen. We might not have known we already saw it, but we've already seen it, right? And the characteristic is that after we evaluate this limit, the answer is going to be infinity. So that's the giveaway. So what would that look like graphically, right? Graphically, that's going to mean, for example, in this case, I'm approaching 0 from the right, 0 from the positive direction. So I'm approaching this, and it's very quickly becoming a massive number, right? The magnitude, the y value as I'm getting closer and closer to 0 is skyrocketing, right? So that's how I know that the limit is going to equal infinity. So another giveaway that I wanted to kind of explore a little bit is the fact that because by definition, a limit of infinity would mean that the value in the y direction is growing infinitely. It means that there almost has to be this vertical asymptote right here. Not right here, but wherever you're evaluating the limit, right? So a limit of infinity will almost always have a vertical asymptote because it's one that will grow in magnitude massively with a very small difference in x movement, right? So there's that. We'll then cover in limits at infinity, right? So a limit of infinity means that the actual limit works out to infinity. A limit at infinity means we're approximating this x value to be infinity and seeing what the function does there. So if we're looking at g of x, if I'm looking at some point all the way over here on that function, the general direction of this function indicates that it's going to end up being 2, right? Because it's getting infinitely closer to this horizontal asymptote. And a lot of times, it doesn't necessarily have to be the case, but a lot of times what will happen is in exam or quiz or homework problems, what will end up happening is if they ask you a limit at infinity, it'll usually have something to do with some horizontal asymptote, whether it's the x-axis and it's like approaching the x-axis this way, or it's approaching some value like this function that I already drew on here. Is there's usually some kind of cap at the y value that it's approaching. So I think the easiest way to explore these problems or these concepts a little bit better is through examples. So let's look at example 3 here, right? We're looking at f of x, and we're wondering what kind of limit is that? Is that a limit at infinity or a limit of infinity? And there's two ways to look at it. I'm sorry, limit at, yeah, or of. So there's two different ways we can approach it. We can either approach it from the graph, right, and acknowledge that the magnitude of the y value of each of those coordinates is getting higher and higher as my x gets closer and closer to 2 from the left side. Or what I can do is I can say, well, if it's a limit at infinity, this number would have to be infinity. Like by definition, that's what the question is asking, right? So this can't be a limit at infinity because it's not asking me to evaluate the function as x approaches infinity. So what this is going to have to be is an infinite limit, which, as we said, is the same thing as a limit of infinity, right? So there's that. Now we've established what it is. Let's actually evaluate it, right? So as we're approaching 2 from the left, this is growing in magnitude incredibly, right? So that has to be infinity. And again, we could have known that right off the bat after establishing that it's an infinite limit, because remember, by definition, infinite limits are ones that equal infinity. Cool. So example 4, we'll move right on. We're looking at g of x, and we want to know what type it is, right? So again, Graphically, we could look at the asymptote, or numerically, we could look at the actual equation, right? So we have a number that's like capping the magnitude, right? So we have a horizontal asymptote, but it's also asking us for x as it approaches infinity, right? So that should be a giveaway that it is an limit at infinity. Ooh, bad spelling. Infinity. Beautiful. So it's a limit at infinity, which means we can't just assume that that's infinity because it's not. So we have to actually look at the graph and figure it out. So as I travel further in the x direction to the right, it's asking me what the function value is. So if I were to go all the way over here, I'm getting closer and closer to 10, right? So that would mean that my limit at infinity is in fact 10. So jumping into two last examples, what we'll do is we'll have to categorize both of them. So this first question, we're going to actually have to do two types. So this first question is asking, we're approaching 0 from the right? So that question, what type is that? That would be an infinite limit, right? And then the second question, we're approaching as x approaches infinity, that would be a limit at infinity. So that one is different depending on how you look at it. And that's an important lesson, because if I just showed you this graph, it could be either. So what you have to do is, if your professor asks you to evaluate which type of limit is exhibited on this graph, it would technically be both, right? Because they're both there, but you would have to ask where, if they were to specify what kind of limit is demonstrated at x equals 0, then you would have to specify, hey, that's an infinite limit. Versus if I said what happens, or what's the limit at infinity, that's obviously a limit at infinity. All right, so let's actually evaluate these. So limit as x approaches 0 from the right, I'm going up here. We already established that it's an infinite limit, so boom. Limit as x approaches infinity, right? I'm going further and further down. I'm getting closer and closer to 0. So there's my limit right there. So this last one is kind of a clarification thing, right? I just wanted to show you that it is possible. Let's look at the type first. So very clearly, I have here, let me arbitrarily call this 2. Oh, wow, it was 2. That's pretty cool. So let me arbitrarily, we'll start with the one from the left. So I'm approaching 2 from the left, boom, 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 boom. What type of limit is that? It's growing in magnitude, so it's an infinite limit. And now I'm approaching 2 from the right, and it's growing in magnitude, right? It's negative, it's decreasing, but it's growing in magnitude, so that's also an infinite limit. So my follow-up question is, both of these answers can't be infinity, or else they'd be pointing in the same direction, right? So my question is, as x approaches 2 from the left, here I go, that's approaching infinity, right? Because it's skyrocketing. As x approaches 2 from the right, what's happening is it's actually going towards negative infinity. And that is a thing. So that was one of the things that I was really surprised by when I first started calculus, is that infinity and negative infinity are common numbers in calculus. So get used to infinity and negative infinity, because they'll be here for a while. But that's really all I wanted to jump through. Definitely practice using both of these terms. Like, I'm sure you'll notice, I try to be super conscious about it, but I'm sure you'll notice throughout the video I probably tripped up a few times, had to think about it, catch myself. It's something that it's like a tongue twister. You'll probably think the right answer, but you might say the wrong one. So just kind of consciously practice identifying them. I think the thing that really broke the code for me was thinking about it not as a limit at infinity versus an infinite limit. It's thinking of it as a limit at infinity versus a limit of infinity. And that at versus of really clarified it, because at implies I'm looking at that location, whereas of implies that that was the final output. So that's really all the guidance I have on this one. If you guys learned something from this video, feel free to like it. If you want to stay up to date on the stuff that I'm uploading for Calc 1 or for other classes, subscribe to my channel and I will post as much as I can. Otherwise, best of luck.